Hey guys, BuildZoid here from... This is what I get for recording a Gamers Nexus video before recording this video. Hey guys, BuildZoid here, and today we're going to be taking a look at another motherboard. And this time it is the MSI X570 Unify. I have really no idea why they came up with such a stupid prefix to put in their motherboard names. It's just like, what does it even mean? And I know what it means, but like, how many people, like, nobody cares what it means. It's stupid. So anyway, we're looking at what at the MSI X570 Unify. There, see, much better. Sounds much better than saying Meg in front of it. Like, who, seriously, like, who came up with that? That's so dumb. Anyway, yeah, this is basically X570 Ace from MSI. Minus all of the stupid things, and, well, one of the good things that the Ace had. So, what do I mean by that? Well, we got a postcode, and you all know how much I love postcodes. We got a reset button, a power button, so we're off to a great start right there. We got troubleshooting LEDs that are right next to each other. So they're actually kind of like, this is my least favorite implementation of troubleshooting LEDs because they're also not color coded. They're all the same color right next to each other. So you're not going to be able to tell what's wrong when one goes off. But hey, you got the postcode. So that complaint kind of becomes irrelevant because this conveys infinitely more, well, not infinitely more information, but far more information than the LEDs do. So, you know, the fact that the LEDs aren't the most, like, implemented the best possible way doesn't really matter that much. You got a clear CMOS button, there's also a BIOS flashback button on the rear I/O, so you can flash the BIOS of this motherboard without even having a CPU installed, and of course rear-mounted clear CMOS, in my opinion, is just like, that's the best place for the clear CMOS, because it allows you to clear the BIOS. Like, if you screw up your overclocking settings, you can clear the BIOS without even having to take your system apart, right? Well, take off the side panel, which counts as taking it apart a little, right? So, yeah, that's a really nice feature to have. Next to that, we got Wi-Fi 6, which I couldn't care less for, but it's a thing now, so here you go. You've got Wi-Fi 6. There's a PS/2 port on this as well, so you know, if you're a IBM Model M fan, that's for you. The other thing is, like, PS/2 always works. Like, there are certain overclocking scenarios where PS/2 can be useful. There's also USB ports under that, of course. More USB ports. There's a Type-C as well somewhere there. And then we've got 2.5 gig Realtek LAN. And this is kind of where we get to the point of, like, well, I kind of wish you had just kept the 1 gig Intel instead, but hey, maybe Realtek LAN isn't as flaky as it was when I last used it. And by flaky, I mean it would drop out every couple tens of hours, which is like, you fix it by restarting the drivers. And it's just like, okay, well, that's not really that big a deal. But the Intel LAN never did that to me at all. So it's just like, yeah, Intel's LAN drivers are at the very least far more stable. But, yeah, maybe Realtek has improved the driver situation, and that just doesn't happen anymore. So, you know, in which case, 2.5 gig is more than 1 gig, and a lot like the other motherboard. Like, the thing is I think this board is like $250, which is absolutely insane, because at this price point, all the other boards are basically 1 gig, and you can forget about having postcodes or power buttons or reset buttons or clear CMOS buttons. So, yeah, you know, like, if we just go off on a checklist of features that features, it's just like, this already wins above everything in its price category, because this, like, it might be $300. I've not made absolutely sure, but it's definitely in the same, like, it's either the same price as a Taichi or less than a Taichi, and that is concerning, because this basically has the same feature set as a Taichi, but it seems to be a bit cheaper, and it has a much better VRM. And I think at this point I've covered all the, like, LEDs, postcode, Wi-Fi, power buttons, yeah. So, oh no, I forgot one feature. So, we all know how much I love dual 8 pins and how completely unnecessary they are on X570. So the thing is, I did not know this because nobody told me until I read a comment from somebody and then actually went and verified it myself and was like, whoa, okay, that's actually really cool. So what is really cool? So the way MSI, so the thing is, normally, right, let's say you stick 3 RX 480s in this motherboard, and then you just overclock them and you don't enable the power balancing system, and you just let them absolutely wail away at the PCIe slots in terms of power consumption. Well, it's not going to be your PCIe slots that end up like breaking. Nah, it's going to be your 24 pin, because the 24 pin has two 12-volt lines, and it's not capable of handling more than 8. Well, MSI's variant of the 24 pin definitely isn't capable of handling more than 8.5 amps, because MSI does not use the high current version of the power connectors for their boards. Yeah, so it's going to melt the 24 pin, and, well, you're going to have a bad day. However, MSI gets around, and normally the way, high-end motherboards get around this is you have like a Molex connector, which I hate, or a 6-pin connector, which I think is good, to provide extra power to your PCIe slots. Now, MSI gets around this by feeding the PCIe slots from the 8 pins for the CPU, which is really cool in my opinion. Like, that is a really great way to make your totally unnecessary 8-pin suddenly very useful. So yeah, like this straight up just powers your PCIe slots, which is awesome as far as I'm concerned. Because the thing is like, here's the thing. Each of these connectors is good for 384 watts. And so let's say you are running a big multi-GPU setup, you probably have a power supply that supports dual 8 pins at that point. So you can just plug in the extra 8 pin and bam, you're sorted with your PCIe power delivery forever. Basically, like, it's not a problem at all. And actually, if you're running any CPU, like, the thing is, on X570, the highest power consumption you're going to run into is like a 3950X doing like 300 watts in Prime 95. That still leaves 84 watts for the PCIe slots if you're running a single 8 pin. And if if you run like a 3900X or a 3700X, or if you just don't run a silly manual overclock, you have way more power available to the PCIe slots. So I actually think that's a really cool way of powering the PCIe slots. Also, the thing about it is, if you're already adding, like, in my opinion, the 8 plus 4 pin combination is even sillier than, say, 8 plus 8 pins, because 8 plus 4... I've never seen a power supply that supports that only supports 8 plus 4, right? Like, I've seen power supplies where you have 2 8 pins, and I've seen power supplies that have 1 8 pin. I've never seen a power supply with an 8 pin and then a 4 pin. Like, I'm pretty sure nobody makes those. Like, those don't exist. So if you're gonna add an 8 pin, like, if you're gonna add a extra CPU power connector, you may as well add an entire extra 8 pin at that point. You could also just use a 6-pin PCIe as well. That would be another option. But I assume the reason why they don't do that is because with this location, it's just like, reaching a PCIe 6-pin up to here is kind of awkward. Though I really think it would be good if MSI, because the thing is, I went through their manuals to check if this was a thing, and it doesn't mention it anywhere. Like, nowhere in the manuals does it say, hey, if you're running quad GPU, like, especially with the Godlike, in my opinion, like, it should say, if you're running quad GPUs on the Godlike, because the Godlike supports quad crossfire, at least if you use old enough drivers, it'll support quad crossfire. Like, it should very specifically say that you should plug in both 8 pins if you're running quad crossfire, because that's where the PCIe slots get their power from. And it's like, it's a cool feature. You just need to bloody mention it, in my opinion. Like, come on. Yeah, and ultimately, the thing is, I also think this is only viable on lower power platforms like Z390 and X570. If you did this on something like X299, well, you'd need another 8-pin, in my opinion. And triple 8-pin is not something I've seen on a power supply. That's not a thing. So 3 8-pins, and actually any quantity of 8 pins higher than 2, in my opinion, is very silly, because most PSUs do not come with that. Even if the PSU is fully capable of providing, if you buy a 1500 watt power supply, it could provide 1500 watts. So if you're going to go past 2 8-pins, you should start using like PCIe 6-pins. And you don't need to use a PCIe 8-pin, because a PCIe 8-pin just adds 2 ground wires. It doesn't actually add any 12-volt wires, so, it doesn't do anything, because your 12-volt line is going to be the one that fails on you, or... Well, it's going to be the one that fails on you if you just use if you use an 8-pin, or if you use a 6-pin, as long as you don't just, well, it's not on a GPU, so you can do whatever you want with it at that point, kind of. So, yeah, that's kind of my thoughts on that. Anyway, cool feature for MSI boards, and I do believe they are doing that for their entire X570 lineup, because as I mentioned, the Unify does it, the Godlike does it, and I see no reason why everything else wouldn't do it too at that point. So anyway... Let's move on to the VRM. And the VRM, on this motherboard is exactly the same VRM you would get on a Meg Ace. Which is just like, well, the Meg Ace is actually the one board where I think having the Meg prefix makes sense because the Ace name is so short. Right? Like that's just a bad name for a motherboard in general, in my opinion. It's just like 2 3-letter words are not a good name for a motherboard. You know, I wouldn't mind if it was like some weird combination of letters and numbers, because then it's like a part number. But when it's like two, like when it's one of them is just a 3-letter word, it's just like, nah, not really a fan. Also, in that sense, what the hell does Unify stand for? Like, what is this board unifying? Actually, they might be like, oh, it unifies cost for per no, that doesn't make sense. So yeah, I have no idea where MSI gets their names. Godlike makes sense, right? Like that board's just supposed to be ridiculous and godlike, and then the creation makes sense because it's for creators. But then the rest of their lineup is just like, who comes up with these? Like, seriously, just randomly go through the dictionary to find a random word, and it's like, that's what we call our motherboard. Anyway, so here's our V-Core VRM, and yeah, it's off of the Meg Ace. It's a 12-phase. It's an old-fashioned style 8-phase, 12-phase, because the board, of course, uses the IR35201, and the IR35201 cannot do 12 phases. It can only do a 6+2. That +2 being, of course, the SoC VRM hanging out right here, which, well, we'll get to that. So the so it's running as a 6+2. Then there's ×2 because there's a bunch of doublers on the back of the board to get us our 12 phases. So that's this one, this one, this one, that one, that one, that one. Man, my photo like the blowout on my photos really kind of annoys me, honestly. Like when I was taking the photos and it was on my phone screen, I was like, it's not that bad. And now it's like, yeah, it's pretty bad, man. It's pretty bad. You need to do something about this in the future, not right now. But yeah, so these are a bunch of IR3599s from International Rectifier, owned by Infineon. These can double, they can quadruple. They do not integrate any current balancing or any kind of logic, well, any kind of like intelligent logic into them. They literally just take your PWM signal and, you know, send it to one phase or the other phase, or if you have them in quad mode, they send it between 4 phases, right? Out of phase. Well, in alternating pattern, so automatically becomes out of phase. But the thing is, the VRM is still getting full 12-phase current balance because the IR35201 controller is actually smart enough to distinguish between 2 phases even after the doubler, or even 4. Like, literally, there's a configuration option on International Rectifier controllers where you just go, like, running with doubler, and it'll be able to distinguish between the 2 phases at that point, or running with quadrupler. So the VRM is fully current balanced. The one downside to using the 3599 doublers is that, well, they add a little bit of delay to your PWM signals. Depending on the transition in the signal, you know, it's anywhere from 5 nanoseconds to 24 nanoseconds. The longest transition is exiting tri-state, which is basically, tri-state is when the power stage basically sleeps. So it's turned off. So yeah, waking up a power stage, that's the slowest transition, even on the doubler. Funnily enough, it's also the slowest transition on the power stage itself. So yeah, but exiting tri-state is the slowest transition. And so the downside to, obviously, this delay in the PWM signal is that you basically take a, there's a hit to the transient response performance of the VRM. However, I'd say if this motherboard has a problem with transient response, it's probably not the doubler's fault. It's more likely that it's this right here doing it. At the same time, MSI, like, this is really funny because the back of the socket looks like major cost cutting took place. And then when you look at the actual power plane of the board, it's just like, well, like, look at all of these, right? So that's all on the V-Core, and it's just like, okay, so I guess those were just deemed, like, the thing is, it is very possible that they just went and tested the VRM and were like, well, if we remove all of these, the transient response gets worse by 5 millivolts. Who cares? Or it gets worse by, yeah, like, it gets worse by such a small, insignificant amount, or maybe it's just like, oh, our transient response under worst case scenario, so like 0 milliohms load line gets worse by 20 millivolts, and it's just like, well, you shouldn't be using that much LLC anyway, so who cares, right? And in the LLC ranges where the motherboard is actually intended to run, like this doesn't actually make a practical difference to the performance. So yeah, though this is definitely something that I want to test because there are some pretty like drastic differences in terms of the bypass capacitors on the back of the CPU socket configurations between the various board vendors. Like Gigabyte, and I think ASRock's doing it as well. Gigabyte and ASRock have the back of the socket looks absolutely insane. Like it looks like they literally just went through, like they went with every capacitor size from 0805 to 0201 and they just crammed as many in there as possible. Then there's MSI who just kind of did this. And then there's Asus who are sort of a middle ground. Like it's not, they didn't go as far as Gigabyte and ASRock with filling out the socket, but it's also like not MSI level. Like, well, yeah, they also are like, they also, I think, removed a couple capacitors, but it's not quite on the MSI level of like, well, this looks rather concerning, doesn't it? It looks kind of unfinished, but yeah, like, I'd be very surprised. Like, I'll try to test for this. But the thing is, I don't have a probinator for X570. But I kind of doubt this makes too much of a difference. Or it's like maybe when MSI was testing it, it was like, oh yeah, it just makes our overshoot worse by 20 millivolts. And it was like, well, overshoot doesn't affect overclocking, so we don't need those capacitors anyway. Which I totally agree with. You don't need extra like if the only thing adding those capacitors back on does is reduce the overshoot, then it's just like, why even bother? Because like it doesn't make the overclocking any better. So yeah, anyway, it's just kind of something interesting that I noticed with MSI boards, and it's just like that I've not noticed with other manufacturers, where it's just like most, like Gigabyte back of the socket completely filled out. Funnily enough, it's just like some Gigabyte boards still don't have the transient response to show for the fact that how their sockets are set up. And then you have like Asus, where it's just like they take a more, you know, I guess measured approach to their capacitor configuration in the socket. And then MSI is just like, yeah, we don't need all of this. So yeah, that's the control scheme of the VCore VRM. So it is a 12-phase. There is a bunch of doublers to achieve it, but honestly, like, I really don't see that having a significant impact on the transient response of the VRM. Like, especially considering that MSI decided that they don't need all of those capacitors. It's just like, yeah, there's the transient response is probably completely fine, and not worth worrying about. So anyway, the SoC is just straight plus 2 phases, right? That's not part of the IR35201's controls. And let's talk about the power stages and the efficiency. So the power stages here are IR3555s. These are 60 amp POW IR stages from International Rectifier. I don't know why I'm doing it like that. And so why am I specifically spelling them out in the IR marketing terms instead of writing it like a normal person? Well, this is the actual product name. But the other thing is these add current monitoring, temperature monitoring, and well, they do also have like body braking mode, and I think they technically have like a unique International Rectifier PWM signaling standard. That's not like there's a different PWM signal standard for all the other power, like for generic power stages, but these also use a proprietary IR standard, which I think allows for, I think it's for body braking mode or like enables some extra features that I can't remember off the top of my head right now. Yeah, that's why these are called POW IR stages. And at 60 amps current rating, they are very, very efficient. And at least until the smart power stages started coming out, this was basically the highest spec of part you could get. The only thing better than a 3555 for a very long time was a 3575, which is a 3555 with a metal tab integrated into the packaging for better heat dissipation. So yeah, you know, like this VRM right here is freaking great. In fact, it's very overkill for the platform, because for operating parameters of 1.2 volts output voltage, 400 kilohertz switching frequency, and 5 volts drive voltage, which is like, well, so you can overvolt these if you want to get more efficiency out of them, but it does shorten their lifespan. There are some GPUs that actually run international like POW IR stages, like 3553s, on 6 volts instead of 5, but these ones here are run off of 5 volts. The end result is slightly lower efficiency, but much extended, like, they last longer. I don't know how much longer. But I'd assume it's a lot because the recommendation from International Rectifier is to actually just straight up run them on 5 volts unless you're desperate for more efficiency. So, yeah, funnily enough, the efficiency curves are spec'd at like 7. So that's, if I remember correctly. So yeah, datasheet is like that's the really fun part. You look at all the efficiency curves and you're like, oh my god, these are incredible. And then you get to the part where it's like, oh yeah, you should run them on 5 volts and your efficiency decreases by this much for doing that. And it's just like, well, thank you very much, datasheet. Anyway, let's talk about the heat output for the various currents. So 100 amps output, which is like maxed out 8 core, 14 nanometer or 7 nanometer. You're going to be looking at about 11 watts of heat. So the VRM literally, if you have a 3700X or a 3800X, you stick it in this motherboard, your VRM literally does not need a heatsink. If you stick a 3600X in this, or 3600, you also don't need a heatsink. You stick an R7 1700 in this, Ryzen 7 1700, don't need a heatsink. 2700X, don't need a heatsink. 2600X, don't need a heatsink. 2700, don't need a heatsink. You get the idea. VRM for the 8 cores, like way too much. 150 amps output. So this is like totally hammering the 12 core with like Prime 95 and ridiculous voltage. Yeah, VRM will produce about 15 watts of heat at that point. You'd probably still get away with no VRM heatsink whatsoever. But at this point, the heatsink might actually be beneficial to the longevity of the components in the VRM because, well, the capacitors, for one thing, don't particularly appreciate running above 105 degrees Celsius. The power stages, on the other hand, couldn't care less. 105 degrees is just fine. Actually, the biggest concern is not these capacitors, it's these, because those are jammed right up against the power stages. Anyway, so 150 amps output, this VRM is absolutely great. 200 amps output, you know what's funny? At 200 amps output, we're still not hitting the peak. Well, I think 200 amps is where the VRM finally starts hitting the peak of its efficiency curve because, well, 100 divided by 10 is 10, not 11. So this is actually less efficient than like 150 divided by 10, which is 15 watts. So the efficiency here is lower than here, which is still lower than here, right? Because 200 amps, 19 watts of heat. So this VRM, honestly, if you're running an 8 core or a 12 core, like, a couple phases should be turning off. Actually, for a 12 core, for an 8 core, half the VRM could probably turn off and you'd still be fine. For the 12 core, you'd probably want to be, like, the VRM would probably want to be running on 10 phases. But yeah, like this VRM is very, very overkill for what it has to do, like for what it has to power in terms of efficiency. So 200 amps, this is like a 3950X getting also just absolutely hammered with Prime 95 small FFTs at insane voltage, manual overclock, and the VRM, we finally need a heatsink. Yay. Or need. Need might be a bit of a strong word, but a heatsink at this point is definitely a good idea. 300 amps output. So now we're going into like extreme overclocking territory, so liquid nitrogen, that kind of thing. 300 amps output, the VRM would produce about 30 watts of heat, which is, the heatsink will have no problems dealing with that. And we'll get to the heatsink, because one hell of a heatsink. Like, seriously, the board comes with one hell of a heatsink. So yeah, 300 amps, heatsink will take care of it. 400 amps, apply airflow to the heatsink and it'll take care of it. 500 amps, you might need a lot of airflow for this, but this is also like, I don't think you'd hit this on even liquid nitrogen, even with the 16 core, so this is not a concern. Basically, this VRM is very much overkill for the platform. I'm really surprised that MSI didn't decide to like lop off these two phases, right? Well, actually, lopping off those two would probably be kind of difficult, but lopping off like these two phases right here would have probably been just fine, because I specifically would have cut out these two because it's like, well, it reduces the thermal density of this set of phases, right? Because there's a great big hole in between 4 and between those two groups. But yeah, it's like, I'm really surprised that they actually kept the entire 12 phase, because honestly, you could drop this down to a 10 phase, and at that point, it would just be equal to the VRM of the Crosshair 7 Hero. Yeah, like, this VRM right here is insane in terms of its power delivery capability. And I'd assume even the voltage regulation, because it really does look like MSI, like, I really don't think they cut off the, like, they wouldn't have cut off those capacitors if they did actually serve a purpose. Because the thing is, even the Godlike is missing a bunch of capacitors. So I think they really, like, they actually tested it and went just like, well, this really isn't making a difference, so we don't need to keep them. Anyway, so we went through all the different currents, and yeah. So VCore on this thing is absolutely insane. Like, well, yeah, it's an absolutely great VCore VRM, and I love this board for it. Like, at this price point, like, below $300, you're just straight up not finding a better VRM than this. Like, it's that simple. Now then, let's move on to the SoC VRM. And the SoC VRM is just more of the same. More 3555s. So when I saw this SoC VRM, also the other thing I like about this SoC VRM is look at all these aluminum polymer SMD capacitors. We all know how I feel about like SMD aluminum polymers. I love them. They're great. Unfortunately, this motherboard has no display outputs. So when I saw this SoC VRM setup, I was like, hell yeah, this thing should be killer for APU overclocking. And then I looked at the rear I/O and went like, aw. So yeah, I'll have to use a different board for that. But anyway, that's my thoughts on the SoC VRM. It's really, really overkill and absolutely great. Like, yeah, love this SoC VRM. Totally awesome right there. Let's move on to other things. Is there anything? Oh yeah, there's the memory VRM, single phase. You've got 2 high sides, 2 low sides, and MSI's DDR, like, memory VRM is one of the more powerful ones, because the high side MOSFETs are 4C029s from On Semiconductor, and the low sides are 4C024s. The 4C024 is a 2.8 milliohm MOSFET, like 2.8 milliohm RDS on MOSFET. It would not be, actually, it would be totally fine. Like, that's a great MOSFET to use even in, like, the low side of a VCore VRM. At least if you, well, depends on how many phases you have, or more like how many of them you use. But 2.8 million, like, the thing is, there's a lot of VCore VRMs out there that use a 4C06N, which is 6 milliohms. So, like, this is a, like, by discrete MOSFET standards, if you're below 3 milliohms on motherboards, that's good. That's really good. You know, the upper limits of low side MOSFETs are like 1.5 milliohms, or there's a couple that are like below 1 milliohm if you drive them with enough voltage. So yeah, these are freaking awesome low side MOSFETs, and the memory VRM on this thing in terms of power delivery capability is just totally overkill. Now the thing is, the memory power delivery is not really that important as what you do with all of your traces is. And in that department, well, we've got a daisy chain, and it's fully shielded because that is a ground fill, right? Like, you can see, like, you can't see any memory traces. The reason why you can't see any memory traces is that's a ground fill. So you've got a daisy chain, it's shielded, and it's a 6-layer board. So, you know, which is kind of why MSI is doing all of the shielding. Like, they're literally just using the top layer and the bottom layer as for shielding instead of actually running any traces over them. So if we go on the back of the board, yeah, there's nothing to see here either because it's all ground fill except like this section right here where you have VCore. And you have the same thing going on the front of the board where, like, there's this island right here, which is VCore. And there's more aluminum, you know, SMD aluminum well, are those No, those look like aluminum polymers. So you got more SMD aluminum polymers on that, because that there's basically a power plane that goes like this to the CPU. And I assume, like, basically this acts as, you know, it helps filtering for, like, these 2 DIMM slots because this is further away. And it also helps for the CPU's memory controller itself. So, yeah. And since this is a daisy chain topology, it biases towards these 2 DIMM. Well, actually, basically every T topology can sometimes just not care which DIMM slots you use, but most of the time, this slot and this slot are the ones that, well, daisy chains bias towards these 2 slots. Also, there's just no, like, with X570, there's no point, like, getting a T topology board. I'm pretty sure actually, no, there might be a couple low-end ASRock boards that are T topology, but, like, all of the high-end boards are daisy chains. And the reason for this is because if you're running 4 DIMMs, you just need to hit 3800 megahertz. Like if the board can do 3800 megahertz, which a daisy chain can definitely do with a Ryzen 3rd gen CPU, then you have all of the memory clock you need. And that's why the daisy chain is so popular, because if you do only run 2 DIMMs, you can do silly things like, 4.6 plus gigahertz memory clock, depending on the motherboard and the memory sticks. But if you're running a 4-DIMM setup, then like you're not going to be chasing frequency records, because the thing is, like, really high frequencies are completely pointless from a performance perspective, because you get the latency penalty going from the because your MCLK ends up desynchronized. Well, UCLK ends up desynchronized from FCLK, and so you get a latency penalty for data trying to get off the unified memory controller onto the Infinity Fabric. And so that just completely tanks your performance. So essentially, your memory layout on the motherboard just has to be able to support memory speeds within the 1-to-1 ratio of the FCLK if you just care about performance, which is why this is like, well, like the T topology isn't going to make the motherboard do, like, sure, the T topology might do, I don't know, 4200, 4400 megahertz on 4 DIMMs. It's just that 4400 megahertz on 4 DIMMs on X570 is completely and utterly useless. So it doesn't do, like, there's no point running that. So, optimizing your motherboard to memory topology for a memory configuration that just doesn't make any sense in the first place is kind of pointless. So, yeah, I'm honestly, like, for X570, I think the daisy chain is the way to go. And, this is actually, like, the thing is with the 6 layers, this is actually the same memory layout as what you get on the Ace, and I do believe also on the Creation. So, yeah, in terms of... And I think actually all of MSI's X570 boards are 6-layer, because I think all of them have memory shields, which you can't do on a 4-layer board. You wouldn't have anywhere to put the memory traces. So, yeah. In terms of the memory configuration, like, this should be, like... I'm really excited to try some memory overclocking, because I have the Godlike. The Godlike's great at memory overclocking, and yeah, I'm really interested to see how, like, this compares to the Godlike, as well as, of course, my X570 Extreme, and then I also have the X570 ITX board from Gigabyte, so yeah, it'll be interesting to see how this compares, because the thing is, like, I have zero doubts that this will do 3800 megahertz. I'm basically just going to do a max frequency test, and I don't really expect to be, like, I expect it not to beat the Godlike, because that, like, the Godlike just has more layers to do the same thing with, so it can do it better. But the thing is, or like the X570 Extreme, or say the ITX, because the ITX just has the advantage of there's less distance and there's less DIMMs. But still, like, I'm interested to see how much of a difference there is going from, like, an 8-layer board to a 6-layer board when it's from the same vendor. Because the thing is, if you're comparing boards across vendors, then it's not really reliable, because you can sometimes end up with an 8-layer board that's just bad. And it's just bad, and it's outperformed by a 6-layer board potentially, and then it's just like from the same vendor you could have a 6-layer that's just better, and then it's just like, well, yeah, this is why you have to test things. Because on paper it might look great, but then it turns out it doesn't actually work. Anyway, so yeah, that's the X570 Unify from MSI, and it's just it's a real shame, in my opinion, that it took them this long. Oh wait, no, I forgot to talk about the heatsinks. So let's talk about the heatsinks. So this is the heatsink assembly for this board, and it is an assembly because this is not what, like, if you've seen any of the pictures of the motherboard, it looks like the entire I/O cover is just one big heatsink. Yeah, no, it isn't. There's a separate plate that actually makes up the I/O, like the cover part of the I/O cover. And this is just screwed on with 2 screws. There's no thermal interface material between this and the rest of the VRM heatsink. I don't really think it was necessary. I don't really think it's particularly necessary anyway, because the VRM heatsink, I mean, you could have more surface area, arguably, but this is still a lot, because, like, these fins are deep and they're long. So, it doesn't look like much looking down on it from above, but this has a good amount of surface area. Far more, and it's also incredibly heavy. Plus, the VRM doesn't put out any heat in the first place. right? And there's also a heat pipe. So this heatsink, which mostly handles, like, this handles 4 of the V-core phases and 2 of the 2 SoC phases. Like, this heatsink is probably going to be dealing with a lot less heat from the actual power stages under it. So if this heatsink ends up warmer than this one, it'll just start putting heat into this one, or the other way around, right? It really, like, I might be completely wrong with my expectations of this heatsink running coolest, but I think this one generally runs coolest. So, you know, the heat pipe is basically there to add extra heat capacity to whichever heatsink is losing in its battle against the heat output of the VRM. Yeah, that's kind of that. So the heatsink's like, so the thing is, thermal testing this board, like, I'm not going to bother thermal testing this because it's just like, it's not going to have a thermal issue. Like, seriously, you'd have to be insane to think that, you know, a VRM that at 200 amps kicks out 19 watts of heat, roughly, is going to have a cooling problem when it has a heatsink that looks like this. Like, it's not going to have a cooling problem. Like, it's not even a question. That's just like, it's not going to, like, that's just a fact. Like, this heatsink is insane. Because the thing is like, yeah, sure, the top plate might not be part of it, and that's a good amount of surface area on the top plate, but this is all surface area as well, right? Just the sidewalls of the cover are more surface area. So yeah, this is one hell of a VRM heatsink. Though I am kind of like, it might, well, no, I don't feel like VR doing thermal testing on this, because the thing is, with a heatsink like this, it is so heavy that I'd be and the VRM on this is so efficient that I'd be very surprised if, you know, you manage to get this heatsink up to like steady state in less than 40 plus minutes. Like, actually, I wouldn't be surprised if it took an hour. Like, honestly, if this took an hour to get up to steady state, I would not be even remotely surprised, because this is such a heavy heatsink. And then if you added thermal paste between this plate and the rest of the VRM heatsink, well, you've just extended how much time it takes to reach steady state. So if you're going to do like steady state temperature, like thermal comparisons for this VRM right here, like you're going to be running the system for like you're probably like, the test period for the system is going to end up being close to 3 hours maybe. Right? Because if it initially takes an hour and then you add more surface area and more mass to it, like, it's just going to make the time it takes to heat up even longer. And I seem to be losing my voice, so I should end this video, because I've said at this point everything I wanted to say. Really, the only 2 complaints I have for this board is that this isn't an Intel NIC, and you know, I might be like, maybe Realtek NICs are good now. I don't know. I've not tested one in ages. I just kind of avoid them, because many years ago they kind of saw, well, yeah, many years ago, it's kind of it doesn't feel like it, but it was many years ago. Yeah, but many years ago, I had bad experiences with Realtek NICs, and I might be completely, like, maybe now they're good now. You know, now they're good. The other complaint is there's only 4 SATA ports. But everything else about this board, like, I love it. And the thing is, it's also not, like, the thing, like, MSI, as far as I can tell, they're targeting this board below $300. And below the $300 price point, I think this thing is absolutely freaking killer. Like, yeah, it's a freaking awesome board for the price. And, yeah, I honestly, like, I feel like it, you know, like, this makes the Ace look stupid, in my opinion. Like, that's the other thing, is just like, the Ace is this, but with 1 gig Intel extra, and the postcode put in a worse location. Like, the postcode ends up here instead of where it is. So it's just like, the Ace is, in some ways, a worse board than this, except that it adds the 1 gig Intel. So, yeah, that's kind of my thoughts on the Unify. Is just like, this is a really, really great board. And apparently, well, no, the thing is, the Ace adds things like RGB, which is a waste of board space, and a game boost knob, which is a bunch of automatic overclocking profiles that I recommend you never use. So, yeah, this is just like, you know, this may very well be my new favorite X570 motherboard, especially if it, like, depending on the price, this thing's freaking awesome. It's got all of the features. It's got a killer VRM. It's got one hell of a VRM heatsink. And it's just like, what more could you want? Maybe more USB ports. That might be one of those things, like, yeah, maybe more USB ports. But, like, Why didn't this come sooner? That's the other question. You know, that's my other question to MSI is like, why did it take so long to launch this motherboard? Like, it's an ace, except not stupid. Why did this take so long to figure out? It's just like, so yeah, I love the Unify. And you know, I can't wait to actually get to test it because MSI did send one of them. So thank you, MSI. And yeah, with that out of the way, well, yeah, that's the end of the video. So thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. And if you'd like to support what I do here with actually hardcore overclocking, I have a Patreon where you can support me directly. There was a police car, I think, going by, so that's why I paused randomly. But anyway, if you want to support me, I have a Patreon. You can find a link to that down in the description below. And if you don't like Patreon, then there is an AHOC Teespring store where you can buy AHOC merch. So there's shirts, stickers, posters, hoodies, you know, that kind of thing. You can find a link to that down in the description as well, and that helps out with running the channel immensely as well. So yeah, if you'd like to help the channel, there's the Patreon and there's Teespring. You can find links to both, and that's it for the video. So thanks for watching, and goodbye.